Alright, so we're going to list all of our elements in a column. H from here, P from right there, O from right here and over there, calcium, Ca, and I think that's all the elements, isn't it? Because H and O show up on both sides. So we're going to do a chart or grid or spreadsheet, whatever you'd like to call it. Notice I'm putting this bar right here, right under the arrow, because I'm showing everything on this side of the equation over here, and everything on this side of the equation over here when I count everything. Alright, so now we're ready to count up all of the atoms we have on either side. So I've got 3 hydrogens here. That subscript after the 3 means there are 3 hydrogens. This 2 outside the parentheses means everything inside is multiplied by 2. So if I have 1 hydrogen in a hydroxide, this 2 means I'm going to have 2 hydrogens. So I've got 3 hydrogens here and 2 here. I have 5 hydrogens. Now if you can't do that math in your head, don't feel bad. There are days when I'm just really tired and not feeling good. I can't do it in my head, and I write it down. Okay, that's the beauty of having this writing instrument here. Okay, I can write it down and keep up with it, keep everything organized. What's the first step in the system we went through in here for determining the methodology of science, the way science really works? Upper left corner was organizing everything you know. Well, this is part of that process. Okay, so I've got 3 hydrogens here. I've got 2 hydrogens here, so I've got a total of 5 hydrogens. Okay, all right, I've got 1 phosphorus. I've got 4 oxygens and 2 more over here. Let's make sure we keep up with it. 4 oxygens here, plus 2 times everything inside. There's an implied 1 there. 2 times 1. So that's 6 oxygens. Okay. I've got just 1 calcium. Alright, over on the other side, looks like I only have 2 hydrogens. Okay, how many phosphoruses do I have? Or phosphori, I guess. How many phosphoruses do I have there? 2. Everybody should be able to figure that out, and if you can't, either ask me to explain it further or whisper to a neighbor to have them help you. Okay? You need to know how to do this. 2 phosphoruses. How many oxygens on this side? This is where you want to write it out. Okay, we got 1 oxygen here. How many oxygens right there? Over here you have how many oxygens? 8, okay. So right now I have 9 oxygens over on that side. And how many calciums do I have? 3. Alright, what are we going to do last? We're going to balance the oxygen last. What are we going to do next to last? Balance the hydrogen. So where do we want to start? How about phosphorus? Okay. So I've got 2 on this side, only 1 on this side. Let's put a 2 here in front of the species that has the phosphorus and recount everything that we just changed, which is almost everything anyway, except for the calcium. So let's see. I've got 2 times 3 hydrogens, or 6 hydrogens. And over here I've got 2 hydrogens. So right now I've got 8 hydrogens. Okay? I've got 2 phosphoruses. 2 times 4 oxygens, or 8 oxygens, plus 2 times 1, or 2. That's 10 oxygens, isn't it? Alright? Well, we've got to save oxygen for last and hydrogen next to last. Got to go to calcium next. Got 3 of them on this side. Remember, once you balance the formula, you cannot touch this.
You can't touch this. You can't touch this. You can't touch this.
Okay? Once the formula is balanced, leave the formula alone. You balance equations with coefficients, not with changing these subscripts. Okay? So I can only use coefficients in front of these species to get the whole thing to be balanced. So I need 3 calciums. I'll put a big 3 out in front of this species. That'll give me 3 calciums. It's going to unbalance the hydrogens and oxygens again. All right. Hydrogens. Got 2 times 3 or 6 here. I've got 2 times the 1 hydrogen times this 3. I got 6 more hydrogens. Does that make sense? Okay. Let's do oxygens now. I've got 4 oxygens in the phosphate times 2. So that's 8 oxygens there. I've got 2 times the 1 oxygen here, making 2. Then times this 3, that makes that a 6. So I've got 14 oxygens. Does that make sense? All right.
Are you not going to change it on the
Hmm?
Are you not going to change it on the AI graph?
Yeah. Oh, that's the wrong one. Oxygens right here. Hydrogen's 8, okay.
Yeah.
Oh, 12 of these, right?
Yes,
Okay. So I've got phosphoruses and calciums balanced. Say what? Yeah, over here. All right, I've got 4 oxygens right here. Okay, and a 2 outside that. That means everything in the formula gets multiplied by 2. So instead of 4 oxygens, we have 8. Okay, and here in this species, I've got 1 oxygen and a hydroxide. The 2 outside the parentheses means I multiply that 1 oxygen by 2, and the 3 outside means I multiply those 2 by 3. So I get 6 then, and 8 plus 6 is 14. Okay, so everything, let's see, the phosphoruses and the calciums are balanced. We need to get to oxygen and hydrogen, and we're still saving oxygen for last. So we're going to balance hydrogen first. The only thing over here on this side of the equation that has hydrogen in it is the water. So I need to multiply the water by 6 to get to 12. Does that make sense? If I need 12 hydrogens, I currently have 2. If I put a 6 in front of this, I will get 12 hydrogens. Does that make sense? Okay. Huh?
I thought you couldn't do that because you got 2 of them. When you go 6 times 1 hydrogen and 6 times the other hydrogen.
Still going to be 12.
If you add them together.
Yeah.
Okay.
Okay. All right. Then we've also unbalanced the number of oxygens here. So we've got 6 times 1, or 6 oxygens. And over here I've got 4 oxygens times 2, or 8 oxygens, and that's 14. And that's why we save oxygen for last. Because most of the time, by the time we get to oxygen, it's already balanced. What she's asking about, we can break, remember the only things you can break up in a complete ionic equation, and you have to do the complete ionic equation first. The only thing you can break up in a complete ionic equation are things that are either acids or they are ionic, and they always have to be aqueous. So acid aqueous or ionic aqueous. Those are the things you break up. So this is an acid and it's ionic. We can break that up. Okay? How many hydrogen ions am I going to have? 6. So I'll write 6 hydrogen ions. And since the whole species is aqueous, that hydrogen ion is going to be aqueous. How many phosphates am I going to have?
4. Oh, wait a minute.
2 phosphates.
Oh.
There's only 1 phosphate in the formula and a coefficient of 2 out in front, so there's 2 phosphates.
Why do you have to do all that?
I'm doing the complete ionic equation right now. There really is no net ionic equation. I'll show you why in a second. What?
The net thing just cancel it out.
Right. But there won't be anything canceling out here. That's what I'm getting to. I'll show you in a minute. Why do we do that? We do that in here because it lays the groundwork for you to understand higher level chemistry. We don't, in this class, ever do what's called redox chemistry. But it's a very important process if you do anything in chemistry after this class. Even in biology, there's a lot of things in biology that have to do with redox equations. So this is just giving you the groundwork for future classes. One of the requirements for a chemistry class is that we provide the prerequisites you need for other classes that follow. So if you're going to take marine biology with Dr. Terry across the hall, you've got to have chemistry 1 CP or honors first, because you've got to know about gas laws, which is the unit after the one we're about to do. It's unit 7. So if you're going to do organic chemistry, there's certain things about organic chemistry you need to know even before you take organic chemistry. If you're going to do, let's see, biology 2, you've got to have a lot of organic chemistry before you get there. And ionic stuff you need, especially when you take biology 2. So if you're going to take a second biology class, ionic formulas are really, really important. Okay? All right, so let's break this next one up then. Can y'all break that up yourselves? Well, yeah, write them out. Good.
How do you know when to break it up again?
It has to be aqueous, and it's always got to be aqueous. But the only kind of aqueous compounds that actually break up are acids or ionic compounds. Nancy?
And ionic is non-metal with a metal?
No, ionic can be either metal or non-metal, or it can contain a polyatomic ion. So, 3 calciums and 6 hydroxides. Okay. Were you successful? Good. Now, let's look on the other side of the equation, because this is what we're talking about here. This is not aqueous. This is not aqueous. They can't break up. Okay? So we just simply write those exactly the way they appear. Okay? And there's a complete ionic equation. Yeah, Dev? Well, hold on. I haven't quite finished here. Okay? So when you have a complete ionic equation, what are you supposed to do to find the net ionic equation? Cancel the spectators. Same thing you said it in a different way. You cancel anything that's exactly the same on both sides. Well, there is nothing that's exactly the same on both sides. There are hydrogen ions here, but they're not ions here, are they? They're hydroxide ions, but they're not ions here at all. These are aqueous, that's a liquid. There's a calcium ion here, but that's not a calcium ion. That's a solid of calcium bonded to the phosphate. I mean, technically it's still structurally an ion, but it's not aqueous it's certainly not separate ions, like this shows. Yes, Katie?
What should we expect the chemical reaction?
Well, wait, I'm still not done here. Hold on, and Dev's ahead of you, so just hold on 1 second, okay? All right, so there's nothing to cancel. So there really is no net. There is no net ionic equation, or you could say this is both the net and the complete ionic equation. I mean, either one really contextually works. That makes sense? All right.